Good afternoon, everyone. I'm super excited to be part of this talk and really glad to see you all. And also, I'm privileged to be part of this talk because Steve Gennard from London Stock Exchange joining us to share their experience on using Azure Event Hubs to build their mission-critical event streaming use cases. Before we dive into that, let me give you a quick overview of Azure Event Hubs and some of the recent feature announcements of the product. All right, so let's get started. A quick show of hand, how many of you are currently using some kind of an event streaming solution such as Kafka, Pulsar, Event Hubs, or any other cloud service? All right, we have a few. I was expecting more hands to go up, but I can understand since it's an integration conference. Yeah. So event streaming and real-time event processing is basically increasing day by day. Especially during last couple of years, we have seen exponential growth of event streaming use cases, adoption of event streaming products such as Kafka, Pulsar, Event Hubs, and all the other cloud solutions. So event streaming is becoming sort of lifeblood of modern enterprises, which enables enterprises to make faster and smarter decisions and stay ahead of the competition. So if you look at any business today, you deal with a wide array of data produced from multiple systems and services. So as an organization, you need to basically capture those events, store them, process them, and generate actionable insights. So therefore, event streaming has been used in pretty much all the use cases that we deal day to day, starting from driving a car to browsing a website. So all the events that you interact with are captured by some system, processed by various services, and business insights are generated. Now, if you look at some of the use cases, we have web clickstream analytics, anomaly and fraud detection in financial sector, as well as analyzing application logs in your software applications, IoT sensor data, real-time ETLs, change data capture, list goes on and on. And when it comes to building event streaming solutions or use cases, you often need to have an event streaming platform. As you can see, basically event streaming platform enables you to ingest, store, enrich, and generating business insights out of all the events that you generate within the enterprise. Now, if you look at the Azure landscape, so this particular diagram depicts the different sources that generate events. You can think of it as triggers or sources, and then in Azure Event Hubs is the main event ingestion service that basically capture all the different events. And then on the consumer side, there can be multiple services, right? Depending on the use case, you can have you can use Azure Stream Analytics to do real-time analytics, or you can do near real-time data analytics with Data Explorer, or you can build your own microservices or function applications based on the events that is residing in Event Hubs. And so likewise, there are multiple event streaming use cases, and there's a separate talk in the afternoon done by Kevin and Ajeta that will walk you through the overall event streaming platform landscape. But for this talk, our primary focus will be on Azure Event Hubs. Now, with that, let's take a closer look at what Azure Event Hubs is. So, as I said, Event Hubs is a real-time event streaming service that allows you to stream millions of events from any source to any destination. If you look at the Event Hubs terminology, it pretty much follows the same architectural patterns compared to other solutions such as Kafka or even other cloud services. So primarily, all the events that you ingest to an event hub can be organized into multiple event hub or topics, right? So you organize all your events into multiple topics, and each topic can be divided into partitions, and partitions is the way that we achieve scalability in event hubs. If you need more throughput, you need more partitions. And on the consumer side, we follow partition consumer model, where you can have multiple consumer instances connecting to different partitions. And on the consumer side also, you can group consumers into consumer groups. And you can think of it as a independent application. So if you need to have the same data consumed by multiple applications, then you need to have 2 consumer groups. So consumer group coordinates the ownership of different partitions across multiple consumer instances. And from the ground up, Event Hub service was built as a cloud native service that supports multiple event streaming protocols. So we have native supports for AMQP, which is used across all our SDKs. And we have native support for Kafka that enables you to bring your Kafka workloads to Event Hubs without writing any code, that which I will discuss later, and also other protocols such as HTTPS. And as I said earlier, Event Hubs also integrates with other services such as Stream Analytics, Data Explorer natively. All right, so then let's take a look at why you should choose Event Hubs for Kafka. Now, another quick show of hands. How many of you are currently running and managing Kafka servers by yourself or clusters by yourself? All right. There are a couple of them. Okay. All right. I think you can create related to most of the advantages that I'm going to explain next. So basically, every organization that we talk to, or every customer that we talk to, want to get rid of managing Kafka clusters or Kafka servers, right? So as part of Event Hubs, what we are doing is we are simplifying your Kafka event streaming experience. So being a cloud native service that enables a stable Kafka endpoint, you can bring in your existing Kafka applications to Event Hubs without writing any single code. So basically, you just change the configuration of your Kafka applications, and then you should be good to go. And also, there can be multiple use cases that requires different scaling, right? So when you are managing a Kafka cluster, you need to think about scaling. You need to add new nodes to your cluster. Now, when you are using Event Hubs, you get a fully scalable. You can scale the workloads from few megabytes to several gigabytes as needed. So you don't really worry about the scaling. Another major advantage that you get with Event Hubs and Kafka is better performance and reliability. So as part of the Event Hub service, we haven't just ported existing Kafka clusters to the cloud and offered it as a managed service. So what we have done was we built our broker engine from the ground up as a cloud native engine, and then we enable different protocols. Now, because of this fact, you can actually achieve better performance than majority of the existing cloud platform as a service providers, and in some cases better performance than running your own Kafka clusters, right? And by default, we provide triple replication across within one cluster, as well as if you are using Azure region that has availability zone support, then your events will be replicated across multiple availability zones without compromising performance or the cost. All right. Another major advantage that you get is cost efficiency. When you are running Event Hubs, one of the main drawbacks of using most of the cloud services out there is the cost. Especially as part of event streaming solutions, you deal with very large amount of cost associated to your Kafka clusters, especially when you are managing it and running it by your own, as well as with the other cloud service providers. You really have to pay a lot to basically stream all the data that you have. Azure Event Hubs is one of the most cost efficient cloud services out there, and there are no specific feature-specific costs that you have to pay. For example, things such as AC support, schema registry, those things are already included features of the product, right? So you don't really have to specifically pay for those features. And being part of Azure, one of the main advantage that you get is all the core services like Azure Active Directory, Azure Monitor, all those things are natively integrated with Azure Event Hubs as well. So therefore, you can get the full power of Azure along with things such as security, compliance, and availability. All right, so with that, let's have a closer look at some of the recent feature announcements. During last couple of months, we have made some tremendous strides towards achieving full Kafka compatibility. So on that journey, we launched during last month's Microsoft Build conference, we launched general availability of Kafka compaction, Kafka Connect, and Mirror Maker 2 support. Now with Kafka compaction, you can basically, it's a new retention mechanism. You can retain different events in an event log using the event key. So you basically retain the last known value of a given event and get rid of the rest, right? So with this approach, if you have events that use the same event key across your event data stream, then you can drastically shrink the event log size. And also, if you have things such as, like, if you want to delete events from your event log, you can just mark a tombstone by setting the event value to a null, and during the compaction, it will delete the events and again make the event log smaller, right? So this feature is been basically, you can use compaction to retain data forever if you need, but adhering to the quota limits imposed across different SKUs. So you need to have a limited size for your event log. And with the introduction of compaction, we also compaction general availability, we also launched Kafka Connect general availability as well. Now with Kafka Connect, you can pretty much bring any of the existing Kafka connectors and bring in different data sources and things. And also along with that, we supported schema registry native integration with Apache Kafka connectors. So one of the other challenge of migrating existing data to, especially from on-prem to cloud services, is to have some sort of a tool to do the migration, right? You need to migrate all the existing topic data as well as existing event data that is residing in your on-prem systems to a cloud service, right? Suppose you have a on-prem Kafka cluster and you need to migrate that to Event Hubs, then Mirror Maker 2 would be the most efficient solution, right? And with the introduction of compaction and Connect general availability, we also announced Mirror Maker 2 support general availability, which will again improve your overall Kafka migration experience. Now, another feature that we launched during build was the data generator public preview. Now, with this feature, you can basically bring in a new sample workloads to Event Hubs. That means when you are building an end-to-end event streaming use case, one of the main challenges is to have some sample data available, right? So with this feature, we have some pre-canned set of data like yellow taxi data, weather data, so that you can use this data to basically, without writing any client code, you can ingest data to Event Hubs and build end-to-end event streaming pipeline. So this data generator will be really useful in the use cases where you have Azure Stream Analytics, Azure Data Explorer, and multiple other consumer services. And with the introduction of, now Event Hubs comes with the built-in schema registry, right? So if you are creating or provisioning an Event Hubs namespace, you have built-in schema registry that comes with it. And we added support for JSON schema in schema registry. We currently have support for Avro schemas in GA, and we included JSON schema support as a public preview for your Kafka workloads. So when you are basically when you are using Event Hubs and schema registry, you can do schema-driven event streaming and use the schema registry as the JSON schema repository. Now, when you are dealing with events, you usually Event Hubs will retain data for a limited period of time, right? And if you need to retain data for long term, or you want to do batch analytics on top of streaming data, you can store data that you ingest into Event Hubs to different storage services such as Azure Storage Services or ADLS. Now, with the capture feature, you can do that within a couple of clicks, and we included support for managed identities for capture in general availability during last month's launches. So now with this one, you can use managed identity with user assigned or system assigned identity, and also you can do cross subscription data capturing too. All right. So during last couple of years, we have done some major enhancements to Event Hubs performance. So we had back in end of 2021, I think we launched Event Hubs Premium, which is multi-tenant offering. And when you think about multi-tenant offering, you always think about cross-tenant interference. How do you isolate your workload? Now, with Event Hubs Premium, we tailor-made this product here to run your workload with isolation. So you would still run the workload on a multi-tenant offering, but you have better isolation across workloads because we offer dedicated compute and memory capacity, right? So with Premium, you get dedicated memory and compute capacity for your workload, as well as we built this queue on top of a new storage engine architecture. We use two-tier storage, basically a local storage which is attached to the broker nodes to optimize performance, and after that in offline we offload the workloads to a separate storage service without impacting the overall performance. Now with this one, we have done multiple performance benchmarking, and for Premium benchmarking we used open messaging benchmarking framework, which is sort of a de facto benchmarking framework used in event streaming workloads. And in the first graph, you can see that we measure how average latency varies between different partition counts, right? So there are multiple partition counts that we use. You can see average latency stay below 10 milliseconds for majority of the workloads, right? And on the second chart, we also measure the predictability, right? In most of the organizations, low latency is okay, but if the latency varies, then it would impact overall business performance of the system. So then we measure the latency predictability with multiple iterations of the same test, and also we compare the same with another cloud provider. Now in this case, you can see we get pretty much the 10 millisecond latency across all our test iterations, whereas the other cloud solution provider has variable performance. Now, Event Hubs Premium is all about running your workloads in a multi-tenant environment, but there can be use cases that requires mission critical workloads that needs zero interference, as well as you need to stream very large volume of data. Now with Event Hubs Dedicated, so Dedicated was initially created for that purpose, but we recently launched the next generation version of our Event Hubs Dedicated clusters. Now with Event Hubs Dedicated, we completely revamped the underlying infrastructure. So we updated the software and hardware infrastructure of dedicated clusters, and then also we adopt the same two-tier log storage engine that we had in Premium, that was battle tested in Premium. Now with all this inclusion, we also included self-serve scaling capability so that you can scale all these dedicated clusters by yourself. By looking at the performance, you can scale it up or down as needed. And we conducted this, similar performance benchmarking against dedicated clusters. Now, in this particular test, we tested with two workloads, 1 megabyte per second and 100 megabyte per second. And as you can see, with the average latency, we were able to achieve 10 milliseconds for the most part with average latency, and for P99, it was well below 30 milliseconds. Now, it translates to 99% of the events that you stream across all these use cases are below 30 milliseconds. Now, if you put this into perspective with other solutions, like if you compare this to running on-prem Kafka, this is basically on par with that or better than running your on-prem Kafka clusters. And if you compare this with other cloud vendors, this is we cannot even plot them in this particular graph. They are very high in both average and P99 values. Now, it's always easy to publish all these numbers and do all these synthetic tests, but the most challenging thing would be to use this test and actually use this product to build a real world mission critical use case using Event Hubs and similar products. So that's where I would like to invite Steve to walk us through some of the use cases that London Stock Exchange has developed, especially using mission critical workloads with dedicated clusters, new generation. Take it away, Steve.
Hi everyone. So I guess welcome. Thanks for letting me come here to talk to you all. I'm not expecting many hands here, but quick show of hands. How many people have experience of trading or of foreign exchange? Anyone? A few at the back. Cool. So I'm here to talk about some work that we've done recently to move one of our oldest and most beloved trading products within the trading and banking group at Edelseg. So the product is called Dealing. It's called Refinitiv Dealing. It has been around since the early 80s. It is one of the oldest, most used products that we have in our business group. It predates the internet. It was one of the first instant messaging applications that really brought around the international FX community. Before this, you'd have to phone someone. You'd have to actually get hold of a person on a phone. You'd have big banks of phones, and this allowed people to digitize it and actually talk over a secure community with your other counterparties, with the people you want to trade with, and it grew over the years. So it's been around for around 40 years. It survived the introduction of Windows. It became a GUI application in the early 90s. It survived the introduction of the internet. Originally, all of this was customer hosted. They would have physical dot matrix printers printing lines of text and screaming away in the corners. It moved to a centrally hosted system, and now, for the past few years, we've been moving it to Azure. So this is one of our main key trading products for those kind of situations where you're doing a trade and you actually want to talk to a person. An automated system just doesn't do exactly what you want, or you want to make sure or double check something. This allows you to have an interactive conversation with your counterparty and actually make sure you both know what you're talking about. And alongside this, this is the latest version. It's aimed at organizations who do trading professionally. So they operate banks of desks dealing with calls that come in at high volume. They come in quickly. They need to complete quickly if markets are moving or there are particular events happening, and you need to respond to many calls all at once and very quickly. This is something that groups of users will share at an organization, and they all pick up calls and they move calls between each other based on who can do which kind of trading. As part of moving to Azure, we've taken the opportunity to modernize this. The original incarnation was set in the 80s, so it's very restricted. We've taken the opportunity to move this forward, so it's a much more modern messaging experience based on how customers have been using this over the past few years. So, at the core of any basic trading system is a very, very simple data pipeline. At either end of this pipeline, you have two people who want to do a trade with each other. One person will start off by saying something like, I want £3 million from US dollars. This runs through our trading system as various stages of a connected data pipeline. It's made up of multiple components, each of which does various enrichment or processing layers that operate as a cohesive chain. So first in here, in that example, we have a part of the pipeline that will convert the text you've written and will convert it into a structured data. It understands what you're writing, and it will extract it into a form that we can process. We validate it. We combine that with other data that we have, such as the price in the market, account details, dates. If you say 1 month, we can tell you what actual date that is, and then you can arrange payment. And then at the end, we have a series of applications which publish this information to those applications that customers are using, or to some of our auxiliary services and feeds. This runs two ways. So there are two people at the end of this pipeline. When you have asked for a particular trade, the person on the other end will normally then send you a price back. Price, I will buy at this price and I will sell at the other price. They don't necessarily know what you're planning on doing. When you actually agree a trade, there are a whole series of flows that then kick in to make sure that regulators and other people are aware of the kind of activity that's just happened. These messages need to be sent to surveillance teams, to compliance teams. They also need to be persisted and auditable. As well as we also have to actually tell customers' own payment and settlement systems, you need to send $3 million to this account on this date. So clearly the data that's sent is very important. Bad things happen if anything goes wrong. And every stage of this pipeline operates as a separately auditable phase. We need to be able to report how fast these phases are working both together and in isolation. We need to be able to add capacity and scale capacity at different parts of this pipeline as usage is growing and as messages are flowing through if there are busy events. And we need to be able to react quickly. If there's a huge market-moving event, people will immediately run to these kind of systems and start trading or start trying to talk and find out what's happening. So there's a very key need for this application to be both highly available, very fast, and also very scalable. So as part of this, like I said, we have various stages in this pipeline. Processing the language, enriching it with data, publishing that to a rule enforcement engine to make sure that the kind of trading that you're doing is allowed and that you are following the right workflow and you're doing what you should be doing. And then we need to update applications and other services that sit on the end as well. Now, our services that we currently have are built around Apache Kafka. Kafka, as Kasun explained earlier, has lots of capabilities to both create a structured pipeline and also to provide the ability to watch and audit services that are happening. So we can create multiple sets of services using different consumer groups that can watch and observe and can intercept when things are happening or when things are not as they should be. And we can make sure that the trading flow is orderly and it's fair. Fairness is a very big part of this. In order to operate these kind of services, you have to make sure that you are operating a fair market. You need to be able to show that the system is not overly pushing data in one direction rather than the other. So being able to measure message latency and each of these different pipelines and report on it is very important to us. So, yes, this one. So some of the work that we've been doing to move these services involved us moving into Azure. We initially started by transitioning our Kafka workflows onto Azure Event Hub. And at the very start, things seemed to be okay, seemed to be functionally okay, and then predictability of the pipeline, the ability for it to operate reliably and quickly started to show some cracks. And this is where we started working with Kasun and his team to try and identify where in this flow is it breaking down, what is actually happening. And over the course of several months, we identified several issues, several kinds of specific items associated with with the data that we send. So the data in trading has strong ordering across messages. You obviously need price messages and buy messages to be in the right order. You don't want somebody to trade on the wrong price, which a lot of the performance test tools didn't actually account for. So our data is quite clumpy. It bursts in particular conversations or particular negotiations at very short notice, and certain the workload across different partitions is not necessarily fully even as it would be in an unpartitioned system. This actually caused some challenges in the way that the Kafka client and the Event Hub service were interacting, which over the course of several months we managed to iron out and improve the overall delivery, as Kasun said, to the point where Event Hub now operates slightly faster than our on-prem Kafka infrastructure does. I think, Kasun, you said it was 10 milliseconds. I think we saw about 8, which is very good. That's very quick. Our application, because it's driving both a UI front-end application as well as all the data processing, it needs to respond on human perception timelines. So it needs to be operating in single-digit millisecond window for us, so that we can make sure that both sides of the conversation are kept in sync with each other, and that all of the trading flow can run at scale and can actually complete a trade in a timely fashion and move on to the next one. And I think that's all I have. Kasun, do you have any more? Thank you.
Any questions? Yep. Yeah, go ahead.
Curious, what happens if the first step fails, the language processing?
If the language processing fail, we have fallbacks to either allow them to continue and refine it, and we have feedback mechanisms that will let you continue. It can learn, yes. It at the moment, I mean, obviously there's a lot of movement in that space. It can learn patterns. It can learn what is happening, and we don't. One of the key aspects of this whole flow is predictability. So we don't allow for learning to affect what is happening, because you can't then understand what the next result would be. If what you said on Monday didn't do the same on Tuesday, that would be a challenge. You need it to be reliable and quick.
All right. Yeah. Probably we can just take one question. Yeah.
Why have you chosen Event Hub over the existing Kafka environment?
So we have tried both. Kafka is, as a client application, is something that we do use significantly internally. The complexities of running Kafka in the cloud, we've tried various different solutions and different vendors. One of the key draws for us, like Kasun said, was the ability to have a dedicated instance with enough storage, enough low latency storage, and the right kind of performance to meet our application, as well as a lot of the auxiliary services around being able to capture and audit. And we have a lot of tools that will measure the performance of a part of a pipeline, and those measurements are quite key in assuring that our service is running reliably and it's running predictably, and that we can actually measure, monitor, and scale it in order to adapt to what is happening and how usage is changing over time. Event Hub was the one service we found simplest to migrate to. I mean, as people said, we actually were able to get it up and running without, we didn't need to change code on our applications. So all of our support tools, all our telemetry, all our performance analysis applications, they all worked as is and didn't really know that they weren't running on native Kafka for the most part.
All right. Yeah. Thank you so much, everyone.
Thank you.